Welcome to 5-5 and 5-7. We are adding and subtracting both like and unlike fractions. Today's key concept is adding like fractions. If you notice in the key concept down here at the example that if the denominators are the same, we go ahead and add the numerator to the top and keep the denominator. So let's try a couple of problems. In this slide, we are adding two fractions. The denominators are the same. The one thing we want to make sure that our final answer is in simplest form. Since the denominators are the same, we can go ahead and put 7 as our denominator. Our numerator, we'll just go ahead and put 3 and 5. 3 plus 5 is 8, and the denominator stays the same. Improper fractions are okay, but in some cases, some teachers like to see a mixed number. So 7 can go into 8 one time. The difference between 8 and 7 is 1. That's our numerator. The denominator stays the same. In this slide, we are adding. We notice that our two mixed numbers have the same denominator. And we want to add and make sure that our answer is in simplest form. There's two methods. Let's discuss both of them. All right, in the first method, we changed our mixed numbers into improper fractions. To quickly go over this skill, we take the whole number and multiply it by the denominator. 6 times 8 is 48. We take the numerator and add that to the 48, and that's where we got 53. The denominator stays the same. We do that for 1 and 1/8. The whole number 1 times 8, the denominator, plus 1 equals 9. That gives us the numerator, the top number, and the denominator stays the same. We can go ahead and combine the top. 53 plus 9 is 62, and the denominator stays the same. That is the answer. Or, if you need to be, it is 7 3/4 as a mixed number. The second method is that we take the whole numbers and combine them as like terms. That's why I get 6 plus 1 and put them in parentheses. That's 7. And then I take the fractions and I go 5/8 plus 1/8 is 6/8. And we can go ahead and combine the two, and we have 7 and 6/8, which, according to the directions, needs to be in simplest form, 7 3/4. As you can see, there are two different methods. You choose which one that you would like to work on. Alright, in this slide we are subtracting or finding the difference, remembering that we must keep our fractions in simplest form. Since the denominators are the same, we can keep the denominator, 20, and we go ahead and subtract our numerator. 9 minus 13 gives us a negative 4 over 20, and we're going to reduce this as 1 over 5, and we're going to continue on bringing the negative over because a negative and a positive results in a negative number. The answer is 1/5. Alright, in this slide, it's a bit different. We have the word evaluate, which means we're going to have to change this expression a minus b. We're going to substitute a and b, which is a is equal to 9 1/6 and b is equal to 5 2/6. Okay, I've plugged in our a and b, and this is what it looks like. 9 1/6 minus 5 2/6. The denominators are the same, so I'm going to use the first method to solve this problem. If you remember, the first problem, or the first method, is to change the mixed numbers into improper fractions. I take the whole number, 9 times 6, 54, plus 1 is 55. The denominator stays the same. Then the whole number 5 multiplied by the denominator is 30, plus the numerator 2 is 32. The denominator stays the same. I subtract the numerator. 55 minus 32 is 23. The denominator stays the same. The improper fraction, 23 over 6, is fine. Or, if you need be, we go ahead and change it into a mixed number. 6 can go into 23 3 times. 23 minus 18 is 5. That goes as our numerator, and the denominator stays the same. In this slide, we are going to find the sum of two algebraic expressions, n over 8 plus 5n over 8. So we know that we have common denominators, so we're going to go ahead and keep our denominators. That means we're going to look at our numerator. I have n, or 1n, plus 5n. Both of these are like terms. That means I'm allowed to add or subtract them. So 1 plus 5 is 6, and we bring the n along. The denominator stays the same. We got to keep in mind that it says simplest form. Our whole numbers are our 6 and 8. As a fraction can be reduced as 3 over 4, and the n remains in the numerator. We come to the second part, our 5-7, where we're going to add unlike fractions. And you can see in the example here is that our two fractions, the denominators are not the same. We're going to have to rectify that by finding a common denominator. In this case it was 15, and when we do that we could go ahead and just add the numerators. Alright, in this slide it says find 1/4 plus 2/3. We do not have like denominators, so we're going to have to find the LCD. We did this in a previous section, so let's go ahead and see what we can do this time. Well, we can list all the multiples of 4, which are 4, 8, and 12. I'll stop there. We can go 3, 6, 9, and 12. You can see that 12 is our least common multiple. Now, we got our two fractions here. We need to multiply both of them by a fraction that will give us a denominator of 12. So we need to say to ourselves, what times 4 will equal 12? And I do believe that's 3. 3 times 4 is 12. And what we do on the bottom, we do on the top. 1 times 3 is 3. So that for 2/3. 3 times what is 12? Well, that's 4. Whatever we do on the bottom, we do on the top. 2 times 4 is 8. We now have our two fractions with common denominators. Alright, put my two new fractions together with the same denominator, which is 12. Add to the top, 3 plus 8 is 11. And then I'm going to ask myself, is this in simplest form? Yes, it is. The answer is 11 over 12. Once again, we have two fractions with denominators that are not the same. We need to find the LCD of 8 and 12. We can list the multiples. We can do a factor tree and find the prime factorization. I quickly listed the multiples of 8 and 12 because these numbers are relatively small. And I noticed that 24 is the LCD. Alright, since 24 is the common denominator, I need to look at 3/8 and find out what I'm going to multiply by 8 to get to 24. And I do believe that's 3. Whatever I do on the bottom, I do on the top. 3 times 3 is 9. So there's my first fraction, 9 over 24. I'm going to go down and look at 7/12. 12 times what equals 24 for my denominator? I do believe that's 2. 2 times 12 is 24. Whatever I do on the bottom, I do on the top. 7 times 2 is 14. And that gives me my second fraction and the common denominator. The denominator is the same, so I keep the 24. Take the numerator, 9 and 14, add them together. I get 23 over 24. Is this fraction in simplest form? Yes, it is. I'm done. On this slide, we have two mixed numbers. We need to add them together, and keep in mind that our second mixed number is a negative. I'm going to choose the first method that we discussed a couple slides ago because it seems to work consistently and it has less steps. So you can see I change 1 and 2/9 into 11 over 9, and negative 2 and 1/3 I changed that into negative 7 over 3. The denominators are not the same. I got to find the LCD, and 9 and 3, well, that's 9. Well, since 9 is the LCD, my first fraction can remain the same because it is 9. I just need to deal with a negative 7 over 3. I need to multiply it by a fraction. That'll give me 9. Well, 3 times what equals 9? That's 3. Whatever I do on the bottom, I do on the top. 3 times 7 is 21. Remembering to bring the negative over. So now I have a negative 21 over 9. I have 2 common denominators. You can see I put the denominator at 9 on the bottom, and then my numerators, 11 plus a negative 21. Well, I changed that plus and a negative into a negative because that's what's the result of a negative and a positive. I'm just going to go ahead and do the math. 11 minus 21 is a negative 10. The denominator stays the same. I can leave it that way, or I can change it into a mixed number. 9 can go into 10 once with 1 left over, and 9. And not to forget that it's a negative number. Alright, since we're adding unlike fractions, we also subtract unlike fractions the same. Where we're going to try to keep our denominators the same by multiplying our fractions by some sort of number that will give us a common denominator. Let's go ahead and try that on our next couple of slides. In this slide we have 5 over 21 minus 6 over 7. The denominators are not the same. We need to look for a LCD for 21 and 7. The LCD is 21. We listed the multiples and you'll find that 21 is the least common denominator. That means that our first fraction, which has a denominator of 21, can stay the same. We just need to adjust 6 over 7 so the denominator is 21. Alright, 7 times what equals 21? That's 3. Whatever I do on the bottom, I do on the top. So I have 6 times 3 is 18. That will be my second fraction, giving me 2 fractions with the same denominator. Alright, I only need the 21 as my denominator. I'll combine the 5 and subtract 18 in my numerator. Go ahead and do the math. 5 minus 18 is a negative 13. The denominator stays the same as 21. Is this simplified? Yes, it is. I'm done. Alright, this slide finds us subtracting again. 2 mixed numbers. The denominators are not the same. I'm going to continue on with the first method I showed you, where I'm going to change my mixed numbers into improper fractions. You can see that 6 1/2 becomes 13 over 2, and 4 1/5 becomes 21 over 5. Now it's time to search for the LCD, or the common denominator, the lowest, of 2 and 5, and that is 10. How did I get these 2 fractions with the same denominator? Well, first, 13 over 2. The denominator is 2. What do I multiply to get to 10? That's 5. Whatever I do on the bottom, I do on the top. 13 times 5 is 65. So my first fraction is 65 over 10. Let's find out what 21 over 5 is. 5 times what equals 10? That's 2. Whatever I do on the bottom, I do on the top. 21 times 2 is 42. My second fraction is 42 over 10. And remember, we are subtracting, so let's go ahead and find out what it is. Alright, the denominator is 10, so you can see I put 1 10 underneath. I took 65 and minus 42. Let's go ahead and do the math. 65 minus 42 is 23 over 10, which is a good answer. Or, if you need to put it into a mixed number, 10 can go into 23 2 times with 3 left over. Denominator stays the same. There's your answer.